Hello students, so today's practical is about rectangular nodes. Myself Dhruv Patel from LJ Institute of Engineering and Technology. So our aim of the today's practical is to find out coefficient of discharge for the rectangular nodes, right? So let us understand first of all what do you mean by nodes and what are the basic properties of the nodes. So first of all, nodes is basically a device by which we can find discharge through the channel, right? So this is a channel cross section, right? So water is flowing through this channel and we have to find out discharge for this channel, right? So we can use so basically if you want to find a discharge through any canal, right? So you can use any rectangular or triangular nodes, right? So in our experimental setup, this is our channel section, right? So this is called as a channel section and this is rectangular nodes, right? So this is side view of the rectangular nodes. Here in this experiment, we have to find out coefficient of discharge of the rectangular nodes. So basically, as we know, coefficient of discharge, that is Q actual divided by Q theoretical, right? So with the use of this equation, we have to find out coefficient of discharge for the rectangular nodes. So nodes is an instrument which is very useful for the mechanical as well as civil engineering purpose also. So let us understand the experimental setup first of all. So this is our storage tank, right? With the use of motor, our water will flow in the overhead tank or we can say channel through the suction pipe and delivery pipe, right? This is our rectangular nodes. From the rectangular nodes, discharge occur in this discharge tank, right? This lever is indicating that here that is a lever operating discharge valve, right? So we can on and off this discharge valve with the use of this lever, right? So this is basically our rectangular nodes setup. Instead of these rectangular nodes, we can easily remove these rectangular nodes and we can easily fit the triangular nodes also, right? But right now we have to find coefficient of discharge for the rectangular nodes. So let us understand the practical first of all.
Good morning students. So today's practical is about nodes experiment. So our aim is to find out coefficient of discharge for the nodes, right? So let us understand this apparatus properly. So first of all, this is known as storage tank. From the storage tank, this is suction pipe, green color pipe, and this is motor. With the use of suction pipe, water will move to this rectangular channel and by the nodes, it will comes out in the discharge tank, right? So this is our discharge tank. So our aim is to find out coefficient of discharge. So for the coefficient of discharge, we have to find Q actual by Q theoretical for the rectangular nodes, right? So we know that for the Q actual, we have to find LBH by time for this tank, and for the Q theoretical equation of the rectangular nodes is 2 by 3 L under root 2G H raised to 3 by 2, right? Where L is equal to width of this nodes, L is equal to width of this nodes, H is equal to height of this water level above the nodes, right? So this is for the theoretical discharge, right? So let's find actual discharge first of all. So for the finding out actual discharge, we have to close this lever operated discharge valve. So let us close this lever operated valve. We can take reading from the 5 to 15 centimeter. Okay, we will close our stopwatch at the 15 centimeter. Okay, so our time required, that will be 16.02 seconds, right? Okay, so for the Q theoretical, we have to measure 2 by 3 L under root 2G H raised to 3 by 2, right? So here in the nodes, width of these nodes, we can easily measure by the scale, right? So width of these nodes, that is known as L, and height of the water above the nodes level, that is known as capital H, right? So with the use of these two reading, L and H, we can find Q theoretical, and after that, with the use of Q actual and Q theoretical, we can easily find CD value, right? For the Q theoretical, let us measure width of these nodes. So we can see here, width of this nodes is 5 centimeter. So width is 5 centimeter and height of the water above the nose level. So we have to measure height of the water is 3 centimeter, right? So L is equal to 5 centimeter and capital H is equal to 3 centimeter. And for the another reading, we have to change this bypass valve position, right? And repeat the same procedure again.
So from the practical, you have seen the methodology of the experiment, right? Now let us do the calculation of the coefficient of discharge. So from our experiment, we got the following reading. So first of all, this is a discharge tank, right? So length of the discharge tank, that is 40 centimeter. We have to deal every unit in the SI unit, right? So 0.4 meter. Width of this discharge tank, that is B, that is 20 centimeter, that is 0.2 meter. Height of the water level in the tank. This is, we can select any arbitrary reading as shown in this practical, right? So in this practical we have select the 5 centimeter to 15 centimeter. So total height is 10 centimeter. So 0.1 meter. Now we want to find coefficient of discharge. So CD is equal to Q actual by Q theoretical. First, let us find Q actual. So for the Q actual, volume divided by time, right? So LBH divided by time. LBH for this delivery tank, right? So here L is 0.4, B is 0.2, H is 0.1, and respective time to fill the tank is 16.02 second, right? Remember this respective time we got from the experiment. Time is equal to 16.02 second. So if we divide LBH by time, we got Q actual, that will be 0.00049 meter cube per second. Now we have to find out Q theoretical. So from the theoretical data, we have the equation of the Q theory. So Q theoretical is equal to 2 by 3 L under root 2G H raised to 3 by 2. Now let us understand nomenclature first of all. L is equal to length of this nodes, right? H is equal to height of the water level above the nodes, right? L is equal to length, or we can say width of the nodes, right? So first of all, this is actual image of the practical setup, right? So this is indicating width, or we can say length of the nodes, right? We can say this is L, and this height above the nodes level, that is indicating our H, right? So from the experiment, we got this length of the nodes is 5 centimeter, or we can say width of the nodes is 5 centimeter, so 0.05 meter, and height of the water level, this is water level above the nodes, right? One second, yes, this is our water level above the nodes. This is nodes base level, and this is water level above the nodes, that is 3 centimeter, so 0.03 meter, right? So our Q theoretical, that will be 2 by 3 L, that is 0.05 under 2 into G 9.81, and H, that is 0.03 raised to 3 by 2. So from the solution of this, Q theoretical will be 0.00076 meter cube per second. Let us put the value of Q actual and Q theoretical in our main equation of coefficient of discharge. So coefficient of discharge, that will be Q actual by Q theoretical. So Q actual, that is 0.00049, and Q theoretical, that is 0.00076. So our CD, that will be 0.65, right? And as this is coefficient of discharge, so it is unitless parameter. So from the experimental setup, CD of the rectangular nodes, that will be 0.65. So from this experiment, we conclude that from the theoretical data, we can get the value of CD between 0.7 to 0.8 for the rectangular nodes, and from this experiment we got the data 0.65. So by this method we can perform experiment of the rectangular nodes.